In this lesson, we are going to start talking about the main part of this unit, which is quadratic formula. This is a formula which is going to be with you for the rest of your education. So please pay attention when we are going to derive the formula to solve quadratic formula. But before we go through finding the formula, let's do a few examples here. The first example is to solve 2x squared plus 5x plus 1 equal to 0 by factoring. Since the leading coefficient is 2, we know that we can't use sum and product. So we are going to use the AC, which is the product of A and C, which is going to be 2, and B, which is going to be 5. Now the question is, find two numbers that the product is 2 and the sum is 5. And it's obvious that we can't find those two numbers. Remember, the two numbers, they have to be integers. So what we are going to do is that we are going to use completing squares. So again, I'm going to take these two first terms, package them together, so I'm going to get 2x squared plus 5x and then plus 1 is equal to 0. From here, I'm going to factor out the leading coefficient, because remember that to do the completing square, we have to have leading coefficient equal to 1, so I get 2x squared plus 5 over 2x plus 1 is equal to 0. Now I'm going to add and subtract half of 5 over 2 squared to the bracket. So I'm going to get 2x squared plus 5 over 2x. Half of 5 over 2 is 5 over 4. Squared is 25 over 16. And subtract 25 over 16. And then plus 1 is equal to 0. Now, I will take these three terms together, and I can write this one as 2. We know that x squared plus 5 over 2x plus 25 over 16 is really x plus 5 over 4 squared, because it's going to give us x squared plus 2 times the first term times the second term, which is going to be 2x times 5 over 4, which is 5x over 2, and then 5 over 4 squared, which is 25 over 16. And then I'm going to multiply 2 by negative 25 over 16. It's going to give me negative 25 over 8 plus 1 is equal to 0. This is going to give me, if I multiply 2 by inside the bracket, I'm going to get 2 times x plus 5 over 4 squared minus, now if I add minus 25 over 8 plus 1 is going to give me minus 17 over 8 is equal to 0. Obviously, I'm going to move negative 17 over 8 to the right, so I get 2 x plus 5 over 4 squared is equal to 17 over 8. Then I divide by 2 both sides, so I get x plus 5 over 4 squared is equal to 17 over 8 divided by 2 gives me 17 over 16. Now, the opposite of a square is square root, so I say x plus 5 over 4 is going to be plus or minus square root of 17 over 16. I move this one to the right, change it to negative 5 over 4, and also square root of 16, the bottom becomes 4. So this becomes x is negative 5 over 4 plus or minus square root of 17 over 4. Now taking the common denominator of 4, I get the answer is negative 5 plus or minus square root of 17. So this gives me two solutions for x, either negative 5 plus square root of 17 over 4 or negative 5 minus square root of 17 over 4. The next example is to solve 2x squared plus 9x plus 6 equal to 0 using factoring. Now again, AC, because A is equal to 2, I can't use sum and product, so I'm going to try AC, which is going to be 2 times 6, which is 12, and B is equal to 9. Now, find two numbers they multiply to 12 and add up to 9. The numbers are 1, 12, 2, 6, 3, 4, or negative 1, negative 12, negative 2, negative 6, or negative 3, negative 4. And none of them, they add up to 9. So I can't use the technique that I had before. Again, I have to go through the technique of completing squares. So I take these two again, package them together, so I'm going to get 2x squared plus 9x plus 6 is equal to 0. Now since the leading coefficient has to be 1, I'm going to factor out 2, so I get x squared plus 9 over 2x plus 6. Now half of 9 over 2 is 9 over 4. I add and subtract square of 9 over 4. So I get, so square of 9 over 4 is 81 over 16. So I'm going to write this one as equal to x squared plus 9 over 2x plus 81 over 16 minus 81 over 16. And then I have a 6 at the end. Now again, this one I can write it as x plus 9 over 4 squared. So I write this one as x plus 9 over 4 squared minus 81 over 16 plus 6. I distribute 2 insides, so I get 2x plus 9 over 4 squared minus 81 over 8, because 2 times 81 over 16 is 81 over 8, plus 6 is equal to 0. Now this is going to give me 2 times x plus 9 over 4 squared, and negative 81 over 8 plus 6 is going to give me negative 33 over 8. Now I bring this one to the right, so I get 2 times x plus 9 over 4 squared is equal to 33 over 8. Divide both sides by 2, I get x plus 4 by 9 over 4 squared is equal to 33 over 16. Taking the square root of both sides and knowing that the square root is going to give me plus or minus, I'm going to get x plus 9 over 4 is equal to plus or minus square root of 33 over 4. Square root of 16 is going to give me 4. Now if I bring 9 over 4 to the right, I get x is negative 9 over 4. 9 over 4 becomes negative, plus or minus square root of 33 over 4, which is the same as negative 9 plus or minus square root of 33 over 4, if you take the common denominator of 4. So you can see that there are two x-intercepts, negative 9 plus square root of 33 over 4, or negative 9 minus square root of 33 over 4. The next example is to solve 4x squared minus 12x is equal to negative 9. To solve this one, I'm going to bring negative 9 to the left so it becomes positive. So I'm going to have 4x squared minus 12x plus 9 is equal to 0. Again, leading coefficient is not 1, so I'm going to try AC. So AC is 36. And b is equal to negative 12. Find two numbers, they multiply to 36 and add up to negative 12. You can see that those two numbers are negative 6 and negative 6, so I can write this one as 4x squared minus 6x. Remember, the two numbers that they add up to negative 12 and multiply to 36 are negative 6 and negative 6. So I can break up the middle term into two terms, negative 6x and negative 6x, plus 9 is equal to 0. I take the first two terms and the last two terms and then factor out the common element, which is going to be 2x. So I get 2x minus 3, and for the last one I take negative 3, so I get 2x minus 3 is equal to 0. 2x minus 3 is common, so I get 2x minus 3 out, and I get 2x from the first, and then negative 3 from the last one. This means that the product of two brackets are 0, so each one has to be 0, so 2x minus 3 is equal to 0, so x is 3 over 2, and the next one the same, 2x minus 3 is equal to 0, so x is equal to 3 over 2. So this means this quadratic has two x-intercept which are both of them are the same. And remember, the way that it looks is a quadratic which is touching the x-axis. Something like this one. Now, all the quadratic equations that we have dealt with, they are easy to factor out. But what about the quadratics that we can't factor? What exactly are we going to do to solve those? This is the main part of the lesson. We want to find the solution to a quadratic equation of the form ax squared plus bx plus c equal to 0, knowing that a, b, c are real numbers and a cannot be 0, using completing squares. What is the general formula? Again, if you want to use the completing squares to solve a general quadratic, I'm going to take the first two terms and package them together. So I'm going to have ax squared plus bx plus c is equal to 0. Now, since a here in general is not 1, I'm going to factor it out, so I'm going to get a x squared plus b over a x plus c is equal to 0. Now, what I'm going to do, I'm going to add and subtract half of b over a squared. So I'm going to get a x squared plus b over ax plus b squared over 4a minus b squared over 4a squared plus c is equal to 0. Now again, these three terms can be packaged together as a times x plus b over 2a squared, because it gives me x squared, the first term, plus b squared over 4a squared, which is the last term, plus 2 times first times the second term, which is 2x times b over 2a, which is going to give me b over a x. And then I also have minus b squared over 4a squared plus c is equal to 0. Now, if I expand this bracket, I get a times x plus b over 2a squared minus a times b squared over 4a squared is going to give me b squared over 4a plus c is equal to 0. Now I move these to the right, so I get a times x plus b over 2a squared is equal to b squared over 4a minus c. Now I common factor 4a, and this becomes b squared minus 4ac. Now I divide by a here, I get x plus b over 2a squared is equal to b squared minus 4ac over, when I divide by a both sides, I get 4a squared here. Take the square root of both sides, I get x plus b over 2a is equal to plus or minus square root of b squared minus 4ac over square root of 4a squared is going to give me 2a. Now the common factor, when I move this one to the right, becomes negative. It becomes x is, the common factor is 2a, and then I get negative b because of this, plus or minus square root of b squared minus 4ac. Now this one is going to give us two solutions, negative b plus square root of b squared minus 4ac over 2a, or negative b minus square root of b squared minus 4ac over 2a. So in general, when you are given a quadratic equations, you do not really need to go through the completing squares. Now you have the general formula for the solution of a quadratic equation. And this is the formula that you have to memorize when you are given a quadratic equation to solve. As I said, when a quadratic equation of the form ax squared plus bx plus c equal to 0 with a not equal to 0 and a, b, c are real numbers, the general formula is x is equal to negative b plus or minus b squared minus 4ac square root divided by 2a. And this gives you two solutions. Now, to see how we use this formula to solve quadratic equations, we are going to use quadratic formula to solve this equation. Now, for the beginning, I'm going to write a is 2, b is 9, c is equal to 6. So I'm going to say x1 and 2, meaning the first two, is negative b, which is negative 9, plus or minus square root of b squared, which is 9 squared, which is 81, minus 4a, which is 2 times c, which is 6, divided by 2a, which is 2 times 2. Now, if you simplify 84 minus 4 times 2 times 6, you get 33. So this gives me negative 33 over 2a, which is 4. So there is going to be two solutions, negative 9 plus square root of 33 divided by 4, or negative 9 minus square root of 33 over 4. Now in this example, we are going to use the quadratic formula again to solve 4x squared minus 12x is equal to negative 9. I'm going to bring negative 9 to the left, so I'm going to get 4x squared minus 12x plus 9 is equal to 0. Again, A is 4, B is negative 12, and C is equal to 9. So I use the quadratic formula. Minus B is 12, plus or minus B squared is 144 minus 4AC divided by 2A, which is 8. Now, if we solve this one, we get 12 plus or minus 144 minus 144 divided by 8. This one is going to give me 0, so the answer is 12 over 8, which is going to be 3 over 2. So again, this quadratic is going to have only one root, which is 3 over 2. Now, if you remember when you plot the quadratic equation, the x-intercepts are the point that the quadratic, the parabola, crosses the x-axis. Now, these x-intercepts are the zeros or the solutions to ax squared plus bx plus c. And we found out that using quadratic formula, the roots are negative b plus or minus square root of b squared minus 4ac over 2a, which represents the x-intercepts of the quadratic. Now, using quadratic formula, I can easily find the x-intercepts, and from the x-intercepts I can find the x and y coordinate of the vertex, and from there I can plot the parabola. Now we are going to find the x-intercepts of a quadratic formula in general form. We are not going to derive the quadratic formula, we have already done it before. So we are going to use the result of what we found before. Remember that when you solve the quadratic formula in the form of ax squared plus bx plus c, the x-intercepts or the solutions or the zeros are minus b plus or minus square root of b squared minus 4ac over 2a. Now, if you remember, to find the axis of symmetry, I'm going to add the two x-intercepts and then divide it by 2. This is going to give me the x coordinate of the vertex. So the x coordinate, v sub x, is negative b plus square root of b squared minus 4ac divided by 2. That's 2a. This is 1 x-intercept plus negative b minus square root of b squared minus 4ac over 2a. That's the second one. And the whole thing, I have to divide it by 2. Now you can see that b squared minus 4ac square root, you have the positive one here, you have a negative one. And when you add them, you're going to get 0. So this one crosses with this one. So what we are left with is negative b plus negative b is going to be negative 2b over 2a divided by 2. 2 goes with 2. So we found that v sub x is equal to negative b over 2a, which is very interesting. If you want to find the x coordinate of the vertex, just find b, find the opposite sign, negative b, and then divide it by 2a. That's going to give you the x coordinate of the vertex. Similarly, to find the y coordinate, put this back in the equation and find v sub y, which we are not going to do it now. And the axis of symmetry, as you know, is just x is equal to x coordinate of the vertex, which is minus b over 2a. The next example is to find the x-intercepts, the vertex, and the equation of axis of symmetry of the quadratic formula y equal negative 5x squared plus 8x minus 3, and then plot it. Okay, to find the x-intercept, I'm going to use the quadratic formula. So I'm going to say x, 1 and 2, is minus b minus 8 plus or minus b squared, 8 squared is 64, minus 4ac, which is going to give me minus 4 times negative 5 times negative 3, which is going to give me negative 60. Divided by 2a, which is 2 times negative 5, which is negative 10. Square root of 64 minus 60 is square root of 4, which is 2, so I get negative 8 plus or minus 2 over negative 10. If I add negative 8 and 2, I get negative 6 over negative 10 is 3 over 5. And if I go with subtraction, I get negative 8 minus 2 is negative 10 over negative 10 is going to give me 1. So now I know the x-intercepts are 3 over 5 and 0, and 1 and 0. These are the x-intercepts. Now if I want to find the coordinates of the vertex, first the x-coordinate is the formula that we found previously, is negative b over 2a, which is negative 8 over 2a. 2 times negative 5 is negative 10, so the answer is 8 over 10, which if we simplify is going to be 4 over 5. Now to find the y coordinate of the vertex, I will substitute 4 over 5 back in this equation for x to find y. So I get y is negative 5 4 over 5 squared plus 8 times 4 over 5 minus 3. I leave it to you to simplify this one. The final answer becomes 2 over 10. So from here, I will find that the vertex has the coordinate 4 over 5, and 2 over 10 is really 1 over 5. So these are the coordinates of the vertex. Equation of axis of symmetry is just x is equal to x coordinate of the vertex, which is 4 over 5. Now plotting the quadratic, I just leave it to you to plot this function. The only thing you have to remember is that the leading coefficient is negative 5, so the parabola opens downward. The vertex is 4 over 5 and 1 over 5. And since we need another point, I can pick the y-intercept, and the y-intercept by looking at this equation is equal to negative 3 when you set x equal to 0. And then you can use the property of axis of symmetry. You can find another point which is the mirror of the y-intercept, so you will have 5 points, and then you can easily plot the parabola. Now the next example is going to be a parabola of the form of x minus 2 squared plus 3. To find the coordinate of the vertex, I'm going to use the general form of a quadratic equation in vertex form, which is y equal to a times x minus h squared plus k. Just by looking at the general form and this equation, you can see that the vertex is at 2 and 3. The equation of axis of symmetry is the x-coordinate of the vertex, so x equal to 2 is the equation of axis of symmetry, and the direction of opening is the leading coefficient, which is going to be 1 positive, so it's going to open upward. Now the next part of the question is determine the x-intercepts using quadratic formula. Now, without even bothering with the quadratic formula, you can see that the x-intercepts, I have to solve x minus 2 squared plus 3 equal to 0. Now to solve this one, I move 3 to the right, I get x minus 2 squared is equal to negative 3. And this one does not have any solution because the square of any number is a positive number and we have negative 3. So there is no solution here to this equation. Now if you want to use the quadratic formula here, the equation is y is equal to x minus 2 squared plus 3. I expand this one, I get x squared minus 4x plus 4 plus 3, which is going to give me x squared minus 4x plus 7. Now, using the quadratic formula, x1 and 2 are equal to negative b 4 plus or minus b squared, which is 4 squared 16, minus 4ac, which is negative 4 times 7 times 1, which is negative 28, over 2a, which is 2. Now, as you can see, 16 minus 28 is going to give you negative 12, and the square root of a negative number is not defined. So this one does not have any solution, exactly like what we did before. Again, I'm going to leave the sketch of this graph to you. You can do it by yourself. But again, we have the following information. First, the vertex is as 2 and 3. The axis of symmetry is 2. Since the leading coefficient is positive, it opens upward. There is no x-intercepts. And also, the y-intercept, you can find it by equating x equal to 0. So I can say y is equal to 0 minus 2 squared plus 3. Negative 2 squared is 4 plus 3. I get 7. So the y-intercept is 7, and then you can go ahead and plot the graph. In this example, I have a basketball which is thrown from an initial height of 1.5 meter. Let's say I throw it from 1.5 meter. It goes up and it hits the ground. The path is given by this equation. H is negative 0.25 d squared plus 2d plus 1.5. The question is that how far the ball travels horizontally, meaning this distance. To do this one, I have to find the x-intercept or d-intercept in this example. Now, to do this one, the d-intercepts are when h is equal to 0. So I have to solve negative 0.25 d squared plus 2d plus 1.5 is equal to 0. Again, using quadratic formula, I get minus b minus 2 plus or minus b squared, which is 4, minus 4, a is negative 0.25, and c is 1.5, divided by 2a, which is 2 times negative 0.25. if you simplify this one, I leave it to you, you're going to get negative 0.7 and 8.7 approximately. You know that the distance can't be negative, so this answer is incorrect. So the answer is 8.7 meter that it travels. Now you may say, what is this negative 0.7? Remember, this is the direction of the path of the ball. But if I continue this one to the left too, which is going to be negative, this is negative 0.7. So it gives me two answers, but one of them is not acceptable. So the answer to part A, how far, is 8.7 meter. The second part of the question says, find the horizontal distance for the basket is at a height of 4.5. This means that instead of h, I have to substitute 4.5 and solve the equation. So I'm going to get negative 0.25d squared plus 2d plus 1.5 is 4.5. I move this to the left, change the sign, so I get negative 0.25d squared plus 2d minus 3 is equal to 0. Again, I use quadratic formula. I get negative 2 minus b plus or minus b squared is 2 squared, which is 4, minus 4a, which is negative 0.25 times a times c, negative 3, divided by 2a, which is negative 0.25. If you solve this one, you get two answers, positive and negative. The positive gives you 2, and the negative gives you 6. So the answer to this part is two horizontal distances, 2 and 6. Now you may again ask, how is it possible? It's very simple. This is where the ball is thrown, this is the ground, and it goes like this one. Now, I want to know the horizontal distance if the height is 4.5. If this represents h-axis, this represents d-axis. Let's say this point is 4.5 meters. You can see that there are 2 points here and here, that the height is 4.5. This corresponds to 2 meters and 6 meters.